Hi guys, we're going to go ahead and do our review for the sampling methods and experimental design. We did these all the way back in the very first part of the year. It's actually Unit 3 of the College Board Review, but we did it first because in a real experiment, sampling and collecting your data and designing that experiment are the first things that you would do in that experimental process. All right. So we'll just kind of go through these notes and review you on all of those things that we learned. First of all, there is absolutely no way to recover from poorly collected data. When we went on our bear hunt, we had visual bias because we could not see the green and brown M&Ms as well as the yellow and orange. So you couldn't go and get more samples and more samples and more samples using that same method because you would continue to have the same bias and thus non-representative number. Okay, so there is no recovery from that poorly collected data. All right, so now one of our common things that we've learned to help counteract that bias when we are trying to collect data from the population is that random selection, or when we randomly assign to treatments. Okay, now you guys know the song very well. Um, to randomize, to reduce bias, but please do not miss out on this part of the explanation when you talk about reducing bias. We want to, if we were doing an experiment, then we want to make sure, or what that bias, that randomization is doing, is attempting to spread any and all traits unknown, and we're attempting to spread those evenly to those treatment groups. Okay, so we never can eliminate that bias, so don't say that ever. We're always reducing that bias. Okay, now we learned about 4 basic ways to select subjects or to get samples from our population in an attempt to try and get a representative sample, because if we randomly select, then our samples, like the population, you can generalize. So we hope to randomly select from the population so that we can and have the right to generalize to that population. With volunteers, which is what typically happens in an experiment, we can't necessarily generalize to everybody in the population, only people that are like those volunteers. All right, simple random sample. Simple random sample, that's our favorite. Put everything in a big bag, shake well to show that we have randomized, and then pull out your subjects and you randomly put some here and some there, or you're randomly selecting them to give them a survey and ask questions. Okay, now here's the deal that you have to know. With a simple random sample, all combinations of samples of a particular size are equally likely. So that's one of the key characteristics that we know about simple random sample. So, in a lot of ways, that's good. If we have 1,000 uh, people, adults, and 500 are men and 500 are women, then there's a lot of samples of size 50 that are a mixture of men and women, randomized mixture of random men and women. But think about it, every single combination is equally likely, meaning it is the same likelihood to get exactly 50 men or 25 men and 25 women as it would be to get that um, sample of all 50 men or all 50 women. Okay, so each one of those samples is equally likely um, in the grand scheme of things. Okay, so anyway, most samples, however, are going to be some other mixture. You're going to have tons that include men and women. It's not, only that one is going to be all 50 men or all 50 women. All right. So, because there are so many other samples that have the mixture of men and women, then the chance of getting that biased group that's all women or all men is pretty small. Okay, it's very small chance, and we might say that's a chance worth taking. We're going to go ahead and account for that. We could also address that whenever we were doing sampling distributions and probability of getting a particular sample, those kinds of things. All right, next, stratified, and then cluster. And you know our favorite song, Hey Cluster, you're a group, I will sample all of you. Hey Cluster. Hey Cluster. All right, so remember that clusters are mini populations, and so that we're hoping that when we randomly select one of those clusters, that we then survey or sample all. I will sample all of you, hey cluster. Well, we say, hey, that cluster was a mini population, so when I take that randomly selected cluster, it's representative. All right. Oh, this is systematic. Sorry, not stratified. Systematic here is that every 10th one. Okay, you pick a number and you line them all up or put them in order and you take every 10th one, every nth one, whatever. Don't forget that randomness comes into play whenever the first subject that you start with is a randomly chosen one. Okay? Another grouping method that is, well, let's see here. I do not see what happened to my oh, there it is. There's my stratified. Okay, there's my stratified sample. So that is the one where we first say, hey, there is something that I need to control and make sure that I get all kinds of items. We did this with rectangles when we sorted them on the page from smallest to largest, and we took some of the smallest rectangles, some of the medium-sized rectangles, and some of the largest rectangles. So we first organized the subjects by a homogeneous trait, a similar subject. So each group is homogeneous. For example, we say, hey, I need to make sure that I get some men and some women because that's a trait that could affect the outcome. So I then would say, okay, 500 men, 500 women, and I'm going to select 25 randomly from the men and 25 randomly from the women. Okay? We do this if we want to make sure that our sample is representative of the population, in that we do not want to leave it to chance to make sure we get that equal proportion of men and women. We don't want that possibility that all 50 are going to be men or all 50 are going to be women. Okay, we want to control that. All right, so there's that. Okay, we've gone over all those sampling methods. Now, if you have a poor type of sampling method, which I actually don't have those listed here, I do on this. Let's see here. I have at the bottom of this page a tree map showing our sampling methods. Okay, so what we have talked about is these good ways to sample. Okay, we've talked about these simple random sample, cluster sampling, stratified. See, we've talked about these good ways of sampling right here. Now, these are two key poor ways to sample. Voluntary response, that's just like letting people call in or letting people send in their card at a restaurant. People are going to fill out the survey card. Well, who does that? Usually the people that feel really strongly and want to make sure they voice their opinion. Okay? Convenience would mean that it would be convenient to ask a particular group. If you stood outside of Brookshire's and you asked people which grocery store they liked better, Brookshire's or HEB, that kind of thing, then it might lend itself to be biased because you could have more people say they prefer Brookshire's or whatever, that kind of thing. So convenience. Now, here are the types of biases that generally result from those poor sampling methods. We've got that voluntary response bias. I talked about that. Only those who feel very strongly will choose to answer the question or put their data into the survey. All right, undercoverage is is what is happening from that convenience sample. It was convenient to go to a neighborhood right after we left school and go collect our data, but that's not necessarily going to be a good representation of all Alito people, because right after school, not everybody's home from work. So you might not get a good representation of all people's views and the proportion of people who eat at home more than twice a week. Okay, you might have more people that eat at home twice a week because you catch those people who are home. All right. Selection bias is that type of undercoverage because you may have made that choice in who those people were going to be. You asked people in the Sierra Club about their opinions on the rainforest. You asked people in the AARP, Association of Retired Persons, about something with Medicare or Medicaid and Congress's votes and that kind of thing. So skewed towards that particular direction. Now, remember our situation with response bias, and that's where individuals' responses can be influenced because of some various reasons in whether it was intentional or accidental, but a bias could occur, which makes it you have more likely one answer than the other. That is not representative of the population. Okay, so remember our question wording. We can have that with question wording. You ask, you first tell people that it we want to preserve the great exploration of the space endeavor, and so then do you want continued funding for NASA, to keep America's great tradition of space exploration going, or whatever. Lack of privacy. You're there with your husband or your wife, and you're asked, if you had to do it all over again, would you marry your same spouse? Okay, so you feel a little bit pressured about how to act because of lack of privacy. Ignorance. People will voice an opinion about something they know nothing about. Okay, we see that all the time, all the time, all the time. Our video that we had at the beginning of the year had the lady voicing her opinion about the rebels of Alpha Centauri and whether she wanted to continue to aid them. And there was no such thing as the rebels of Alpha Centauri, and yet she voiced an opinion as that she did not want to continue supporting them. All right, and appearance. So, how somebody looks could affect the way in which somebody answers. I had a pair of students. One was a boy, one was a girl. They were going and asking people just about which bank they used in Alito. And the people that were asked by the boy didn't want to answer. They felt uncomfortable doing that. They were okay with answering to the girl. I guess they weren't intimidated, but apparently the boy scared them a little, and they did not want to divulge their banking information to a young man. All right, appearance could affect that. So again, here is that tree map of those sampling methods. And here is a summary of those types of bias that those poor sampling methods do. So here we have that voluntary response sampling, which then results in voluntary response bias. Our convenience sampling results in that undercoverage. It was convenient to ask those AARP members, but that was not representative. It was undercoverage. You can have those response bias, those poor interviewing, lack of privacy, all those things. That's your response bias. You could also, and I didn't mention this, but you can have where you go after school and basically nobody was home, and so you had a refusal to answer. Or maybe with that example with the young man, with the boy and the girl asking about the banking information, maybe if he was the only one collecting that data, he would have had so many refusals to answer that he would have not had a good representation because of that non-response to his question. All right. Now, experimental design. This was the next section. So there are many keys that we need to pay attention to with observational studies versus experiments. Those are two different things. They are both types of studies. They are both attempting to compare groups or compare these variables and the relationship between things that are going on. But there are very different conclusions that we have the right to make. There are different ways in which these studies happen. Okay, so I went ahead and you can see here with this double bubble map, those things. Here on observational studies, we are generally randomly selecting them, and I have that noted down here, that we have random selection of the subjects. And so if you're randomly selecting from the population, then you can generally generalize to the population, okay? But with experiments, a lot of times these are volunteers. And so because we have these volunteers, then we can only generalize to volunteers or people like those volunteers. All right, next. We know that the design of an observational study is that we have to just observe already existing conditions. We identify these, we either identify them right here and then follow and see what happens and just naturally, or we identify some people and we look back at past records. Something, hopefully it's reliable, not just anecdotal evidence, okay? So observational study, observing already existing conditions. However, experiment, the thing that identifies an experiment is that we are actually imposing a treatment, forcing something upon these subjects. I mean, they're volunteering for it, okay? So the key is that we randomly assign. So where the importance comes in with these experiments is that we take those subjects, put them in a bag, shake them well, and then randomly assign some to one treatment and some to the other treatment. And with that randomness, we are hoping to reduce bias by spreading unknown traits evenly to those treatment groups. Okay, mixing up anything, get it same type of people here and same type of people there, so that the only difference between these two groups is the treatment. Okay, so that random assignment to the treatment groups is what's happening in an experiment. All right, and finally, we know that because of random assignment to the treatment groups, where the only thing different between them is the treatment, we can then infer cause and effect. Okay, that's important. Let's see, what is the principles of an experimental design? And then we know when you make an experiment, you must randomly assign to make the groups the same, so the treatment is the why, the cause and effect. And we know that at the end of the principles of the SpongeBob song, um, let's see, control, randomize, repeat. You make an experiment. What you do? Control, randomize, repeat. You randomly assign to the treatment groups so you can claim the cause and effect. Okay. Now, with observational studies, we can generally say there's this correlation or there's this relationship, okay? We can say correlation or relationship, but there's other things involved. We can't say cause and effect. For example, as much as I would love to say something like this, you cannot say cause and effect. You can't say music causes people to be smarter. Okay, tried to do that with Mozart effect and all those different things, but no, you cannot say that. Why? Well, you've got more involved parents who are getting those kids to those music lessons, who are more affluent. They are paying for those music lessons. They are paying for that stuff. Those are also the parents who make their children pay attention in school and do their homework and have higher grades and all of that kind of stuff. And then all of that builds up to higher SAT and ACT scores and all of those kinds of things. So we can make that association and that connection, but we cannot say one causes the other. Okay? All right. Now, down here at the bottom of this page, oh, just FYI, with observational studies, we can either look back, retrospective at past data, or we could identify kindergartners or whatever, and then now I look forward and follow them for a certain amount of time, okay? Whereas experiment, we're only identifying, assigning a treatment, and then moving forward. So, of course, experiments are prospective only. All right, so those key things that I just talked you through, here are those key takeaways that you could go through and read, but these are the main things that you must know about the differences between those observational studies and experiments. Okay? All right, a couple other things. Let's remember some of this vocabulary. This unit was so rich in vocabulary. Our control group, that's either the group that does not receive the treatment or they are receiving that current treatment on the market. Okay, you wouldn't want to give people comparing toothpaste, make one of them not use any toothpaste at all. Okay, that would be mean. And that would be something that could cause detriment to those people. So they could have the current toothpaste and then the other people have the new toothpaste. All right. And remember, blinding, that's where we make it such that either the participant or the participant and the person measuring the response do not know about which treatment is being received. Okay, we might consider, when would you want to do this blinding? You would want to generally do this blinding if a behavior would be changed because you are in this experiment, or a behavior would be changed because you think that you are getting a particular treatment. Okay. Of course, psychological things like how you feel, how you look, if you think your hair is doing better with a particular shampoo, or you feel better with a particular medicine. Okay, all of those things for sure. But even with some things such as measuring your cholesterol levels, okay, if you're in this study, then you might change the behaviors of what you eat, how you exercise, other things that might affect that cholesterol other than the medicine itself. So again, in that case, we might want to hide from the patient which treatment that person is receiving. Okay, remember, single blind is only the subjects are blinded. Double blind, both the subjects and the evaluator, the doctor, the nurse, whoever's collecting that data, do not know which treatment the patient is receiving. Now, somebody somewhere knows, so don't think nobody knows and that can't ever happen. The lab tech knows. The lab tech can align those um, patient numbers and results and then make a conclusion. Okay? All right. You know that those placebos are those fake inactive substances like the sugar pill, a saline injection if the medicine was done that way, a placebo surgery, we had that article about, other procedures. Okay. That placebo effect is that change that's happening from nothing to thinking you're taking something. Okay. Like, I think I feel better just because I'm taking a pill. So then what I would do is compare the real pill's results to the placebo's results. Okay, not to necessarily nothing at all. So you might have a little improvement because just you think you're getting the pill, okay? But then is there much more difference because of the actual medicine? Okay. All right, and those confounding and lurking variables. Remember, confounding variables cloud the issue. You can't claim a cause. Our example we had was tomato plants somewhere in the shade, and we're not taking the fertilizer. Some were in the sun and were taking the fertilizer. Well, that's two variables. You can't claim which one is the cause of the improved tomato production, okay? You want to control those items. That's a lot of times what we are doing in confound or in blocking when we do an experiment. We're trying to control. We think the fact that you're a man or a woman is going to affect the blood pressure, how the blood pressure medicine works. So we make sure we block you into homogeneous groups so that that's not a confounding variable that could happen. All the new people get something and make it seem as though, or all of the women get the new medicine, and then you can't tell, is it because they were a woman or is it because they were the new medicine that the results were better. Lurking variables, make it look like there's a link. Okay, this is happening a lot in those observational studies. I can't tell if people are getting higher SAT and ACT scores because they took music lessons and music lessons make them smarter. Okay, or, or is it the fact that caring parents, affluent parents, have them take music lessons? Caring parents, affluent parents, maybe are smarter themselves and pass on those smarter genes. Caring parents, affluent parents, enforce or have the importance of education to the children. Okay, so that lurking variable of caring parents affects both outcomes. You go into music and you are more educated, and then the result is higher SAT scores. The example we had in school a lot was that size of the fire affects the number of firefighters that go to the fire and the amount of damage. The firefighters are not the cause of all the damage. Okay, bigger fire causes more firefighters. Bigger fire causes more damage. Firefighters are not the cause of the damage. Just because there's a correlation does not mean causation. Okay? Just because you did music doesn't mean you get the higher SAT score or whatever. Anecdotal evidence, that's just when we're doing those observational studies, if we are collecting retrospective back there data, we want to look at data that's reliable, such as medical records, past medical records, okay? Taking somebody's account of what happened, that's not a reliable source of unbiased information. So be mindful of that. All right. And finally, our types of experimental design. You make an experiment. What do you do? Control, randomize, repeat. Okay, the principles of experimental design. The controlling methods we have, we try to do that randomization to reduce bias and spread unknown traits evenly. We are doing that with a completely randomized design where first just everybody goes in a big bag, we shake well, and then we distribute the subjects evenly to the treatment groups. However, if we think there's something we need to control, we can do that with the block. Okay? Remember this. Blocking reduces variation. Blocking reduces variation. Okay, that blocking is going to make those homogeneous groups. Okay, let's see, I don't remember how the start of that song go. Um, I have the songs listed there, so all of these things that I've kind of been singing off to you are here. For the blocking, I see you have a trait there that may affect the way subjects respond. I see you have something, gender might affect the way people respond to the medicine. Okay, their hormones, more estrogen might affect the way that the medicine works. Okay, whatever. If you see there's a trait that just the characteristic the people or that the subjects inherently have, then you have to control that. And control Randomize, repeat. Control happens first. Block first. Don't randomize into the treatment groups and then block. No. Okay. So what we want to do is we want to make those homogeneous groups first. I'm going to make the homogeneous groups, make them the men, make them the women, or whatever. And then within each block, I'm going to do that experiment. So I'm going to take all the women, and then those women I put in a big bag, shake well, and separate them into the treatment groups. Okay? Perform that experiment. All right? Then with the men, put them in a bag, shake well, perform the full experiment. Randomly assign them to the treatments, perform the full experiment. Now, final thing that I see as a common mistake, do not at the very end compare the women's results to the men's results. Hello, you separated them for a purpose from the very beginning because you knew that they were going to have different results. So, no comparison needed at the very end between the two blocks. You're only comparing within a block. The men on the treatment A to the men on the treatment B, they get compared. The women on treatment A, women on treatment B, they get compared. All right. So there we go. There are those things that I said about that. Pretty much I just discussed with you, and you are welcome to read through these bulleted items. I worked really hard at how I worded them to basically say what I just did. Okay. And then the final. Oh, key here though with just simple blocking is we're pretty much in this course, we just go through the blocking. If you see there is one particular trait that you need to control. Okay. It's led you in the wording to say exercise affects cholesterol in addition to the medicine. Okay. Well, then they want you to control the exercise level. And I have an example later in these notes if you wanted to read that. All right, so we're doing one trait. Now, if there are many traits, a special case of blocking is matched pair, and that's happening when there are many traits, multiple traits that you need to control. Okay, so we're doing the gas mileage and the where people drive, the kind of vehicle people drive, the way in which they drive, if they're lead-footed, if they're highway drivers, city drivers, so many different things that contribute to the gas mileage, okay, that we might want to do a matched pair. All right, now, so those subjects will be paired, and there's two kinds of matched pair. You can either be matched with a twin that is almost identical in the important ways that affect the response you are measuring. The important thing about blocking is you are choosing to block by a trait that affects what you are measuring. If we're measuring gas mileage, then the color of the car has nothing to do with that, okay? So that's not a trait that I need to consider controlling, okay? The trait that you want to control are the ones that are going to affect that outcome you are measuring, that response. All right, so you either have twin drivers who do the same kind of driving, same kind of car, same kind of yada yada, and then you can say randomly assign one of each pair to that kind of gas or that kind of gas. Okay? Now, that might not work. And so then you might not be able to find identical enough twins. But you could do this other thing called a crossover design. This crossover design is where subjects are their own matched pair. That's like when you have somebody before and after when we collected our data. In this case, it could be that the subject is its own matched pair and they will do one type of the premium gasoline and the regular gasoline. Okay? In this case, random assignment happens with which treatment is done first. So if this person is going to drive a month on one type of gas and a month on the other type of gas, random assignment into which one is done first, okay? So that we have half of the pairs doing premium gas first and half of the pairs doing the regular gas first. That helps us make sure that the order in which you use the gas is not a confounding variable that affects the results. All right. So in the end, then, remember how we would test these? We would do that one mean. We would get that one mean of those differences and compare that to no difference at all. And here is if you're a visual person or you just want to see it kind of all laid out, here it is. I think this is a very helpful map. Here's our completely randomized. Read through these. Okay. I really want you to read through these. Randomized block, they have that one main trait. Matched pair have many traits, and they can be twins or crossover, and so on and so forth. So take a few moments, read through that thinking map. All right. And then here are all these songs, which I've left a link in the notes on Canvas to the playlist of the YouTube videos for that. Okay. And then what I have here that you could look through, with this document, and I'm not going to go through it with you. I want you to just read through it. So here is 3 problems, and they are free responses. And so what I've done is I've put the answer in there. So you can see I put the answer there in red. I typed it out so you could see it. And you could see, it's very very straightforward as to the type of information that I need to include. Just make sure that when you answer questions to these free response problems, that you not only state and indicate what the definition is. For example, can you use blinding with this problem? Should it be single or double or whatever? You state and make it clear that you understand what that blinding means and is doing, but not in just generic terms, and you say how you could do that in context of this problem. Okay? So I've given you that example in these items. And so I thought these were a good collection of how to handle experimental design problems in free response format. In addition, do you remember StratMeCapped? Start with the subjects that you have randomly. Assign them with a big bag. StratMeCat, do-do-do-do-do-do. StratMeCat, do-do-do-do-do. Shake your bag up. Shake your bag up. Treatments. State your treatments. Very well. Measure each subject's response to them. StratMeCapped, do-do-do-do-do-do. StratMeCapped, okay? Compare the average or the proportion to see if one of those is significantly better, okay? So this was me going through a StratMeCapped, and I kind of bulleted those so you could easily see that part of it. All right, see, could this be described in a double-blind manner? And I said very clearly, yes, definition, and then how they could do that in context, okay? So I want you to read through those problems so that you have a clear understanding of the way to answer these questions so that it is clear you understand experimental design and sampling methods and in context of the problems, okay? All right. Thank you very much for these, and I hope this helps you when you do your AP questions.